Okay, fine. So let us start combinatorics, and we will discuss combinatorics and some problems related to it, and probability and expected value. Probability expected value would be covered by Bharat sir, and I will discuss combinatorics and probability. Actually, these topics why we are discussing is that these topics are sometimes directly asked in in the form of MCQs of some companies like Goldman, and some of the companies are directly these problems, as well as in competitive programming also. You will find that many problems this foundation of these topics, and if you know these topics, then you will be easily able to solve. Otherwise, many times it happens that you are weak in these topics and you get stuck on such problems due to this. So today we'll discuss some problems also related to these topics of competitive programming also, and some normal, some easy, some of the easy problems also. So okay, let us begin. So, first of all, let us start with one of the basic things of combinatorics, which you all might be knowing. Still, I should tell you so that. Uh, okay, so one thing is like one is sum rule and one is product rule, and one is sum rule. So, product rule is saying that suppose you have to do two jobs. One is job A and one is job B, such that job A can be done in some m ways and job B can be done in some n ways. So it is something like if any job or anything A can be done in m ways, and after that, after performing, once you have done the job A, now after that, after it is done, you have to do some job B which can be done in another job B, can be done in some m ways and n ways, let us say. Okay. So what is the total number of ways? If this is the condition, then total number of ways to perform or to do both, means to do both A and B is m multiplied by n, in m multiplied by n ways. So because sometimes it happens that when you are solving problems related to dynamic programming or some of the topics in which combinatorics is involved, so sometimes people confuse कि multiply कब होगा, add कब होगा. So this is very means foundational thing, basic thing which you should know, कि whenever some of the you need to perform two tasks, and such that you need to perform both of the tasks, and you can say that after one task is performed, then you perform the second task. It is like that. So whenever such a thing is there, that time you multiply things to get the number of ways. So I will give you an example. It becomes more clear. So let us say you need to form a team of let us say of one. You need to form a team for ICPC. ICPC, you all might be knowing, is a competitive programming, like Olympics of competitive programming. So you have to form a team for that, and it should contain one mathematician and one programmer, and let us say it should contain one, what to say, one, let us say one gamer. Okay. So and there are total, let us say, 10 mathematicians and 15 programmers and 5 gamers in your college, let us say. Now you need to answer in how many ways uh, can you form your team. Can you form a team? So the number of ways in which you can form your team. Try to answer. So try to break it in parts. Like if you want to form a team, you need one mathematician. So how many ways you can get one mathematician? So try to answer in live chat if you know, means if you know how to calculate it. It's easy. Like you need to select first one mathematician. So in how many ways can you select? You have total 10 mathematicians. So obviously in 10 ways you can select. Okay. So mathematician in 10 ways to select a mathematician. And if you have 5 ways to select a programmer, and you have again 5 ways to select a gamer. Now here we need to select all of them. Here and is important, means every task we need to do. We need to first select a mathematician, then a programmer, then a gamer. So everything we need to do. So and is there. So we multiply these. We are not adding them. Why? Because and is there. So product rule says multiply them to get the total number of ways to do all of them. So we will multiply them to get the total number of ways. Okay. So the total number of ways will be 15 into 10 into 5. Total ways equals to 10 into 15 into 5. Fine. Now let us consider the sum rule. So sum rule क्या होता है? Sum rule is just similar to that, but instead of and or is there. So it is like you need to perform two tasks, but you need to do any one of them. Break हो रही है voice क्या? अच्छा अब बताना अगर ब्रेक हो तो. आई थिंक अब नहीं होनी चाहिए. ठीक है. अगर अब ब्रेक हो तो बताना. Okay, so if a job can be done in n ways and another job can be done in n ways, and you need to do only one of them. So like similar to the above, but any one you need to do. So that the answer for that will be m plus n. Like you need to do if a job a can be done in m ways, and after it nahi, ab matlab ki, and another job b can be done in m ways, and then the total number of ways to do either a or b. Anyone, you need to do any one of them. So either a or b is m plus n ways. So this is the sum rule. Okay. So if we have the same things, if we have the okay. So if we have the same question, but now the question is little bit changed, that you need any one of them, either a mathematician or a programmer or a gamer. So what will be your answer to form the number of ways to form a team? So you need okay, so you need to form a team for ICPC of one mathematician or one programmer or one gamer, anyone you need. So what should be your answer? 10 plus 15 plus 5, right? So your answer would be 30. Okay, 30 ways are there. So this is one of the basic thing, and similarly you can also consider one more example if you want. Ki suppose you are at A, and to go to B there are m ways, and from B to C, if you want to go from B to C, then there are n ways. So how many ways to go from A to C? So the answer would be, first you need to go to B in m ways, any ways you can go in m ways, and then you after that you need to go to n. So you need to go both. You need to first go to this and from A to B, then B to C. So you need to perform both of the tasks. So multiplication would be there. So the answer of this would be m into n. M into n ways are there to reach C from A. Okay. So one more example. This was. So I hope it should be clear now. So when to multiply and when to add. Okay. Now let us take one more example. For take one more, let us see one more thing. Like if you want to arrange n things, uh, so number of ways to arrange n people. Let us say arrange in n people. So here we need to n people are standing somewhere, so you need to arrange them. What are the number of ways to do that? And distinct people, you can say, people, or the people are different people, and distinct objects also, you can say anything you can take. So how many ways are there to arrange them? So try to answer if you know. There are n distinct objects or people, and you need to arrange them. What is the number of ways to do so? इतना तो आता ही होगा, नहीं आता क्या? ओके. ओके, सो इसको भी सिंपल इससे प्रोडक्ट रूल से देख सकते हैं. लाइक इफ यू सी द प्रोडक्ट रूल, so we can break the things into smaller tasks. So like we need to arrange n objects. n फैक्टोरियल सबको पता है कैसे आता है n फैक्टोरियल, तो उसका सिंपल सा तरीका है कि जस्ट कंसीडर द फर्स्ट पर्सन. So suppose there are n places, there will be n places total. So first person can be occupying any one place. So what are the number of ways to arrange the first person? So there are n ways for the first person. ठीक है. Now first person is fixed somewhere. So let us say I have fixed the first person here. So this place is occupied by someone. Now there are n minus 1 places left. So for the second person, there are n minus 1 ways to get any one seat. Similarly, suppose now second person has also occupied any other seat and it may be anything. Now the seats left would be n minus 2. So for the third person, n minus 2 seats are available. In this way, if you continue this series, if you continue with this multiplication, you will get that until you need to do up to 1. So this is called factorial, n factorial. Okay, so the answer would be n factorial. So this is also called n factorial. So it is matlab you can see n factorial, or n factorial can also be written as 1 into 2 into 3 into up to n minus 1. In the reverse way also you can write anything. So now this is number of ways to arrange distinct people. Now suppose you have something like this. So you have, I want to ask you uh, how many ways, how many different arrangements of this set of letters is possible. So you have a set of letters and you can arrange them in any ways you want. So these are the set of letters: A, B, 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 C, 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 something like this. So there, how many arrangements are possible? So there are 3 A's, 4 B, and 3 C. So you can arrange them in any way. Like one arrangement can be like this. 1A can be at the last something. This is one arrangement. One arrangement is something like C. This C can be here. So the total number of A's and B's and C should be same, but in how many ways you can arrange them? So there are here 3 A's, 4 B's, and 3 C's. You know that if these all characters were different, let us say, then what would be the total number of ways? That would be 3 plus 4 plus 3 means there are total 10 characters. So 10 factorial will be the total number of ways if they were different. But since these three are same, so these three can be arranged in themselves in 3 factorial ways. So we will divide by that because we need not count that. So the answer would be 10 factorial divided by 3 factorial multiplied by uh, 4 factorial multiplied by 3 factorial. Okay. Why? Because these three are equal. These three are same thing. So their you can say their arrangement do not matter. So they can be arranged in 3 factorial ways. So we need to divide it by that. So similarly, because these are same, similarly these 4 are same. So I divide by 4 factorial. Similarly, these 3 are same. I divide by 3 factorial, like this. Okay. Total number of ways, if they were different, then the total number of ways was only 10 factorial. But since some of them are same, so I divided it by this. So this is one more type of problem. Now let us see, like okay, so let us come to permutation and combination. So like permutation and combination, and you all might be knowing. So what is permutation? So permutation means, like, if you are given n objects, like if n objects are there, we need to select any ordering of R objects. Matlab there are n objects, but you need only R objects and their order matters. So you can say order matters. So what would be the number of ways to do this? Like, it can be anything. You have n objects and you need to select R objects, but their order matters. In what order you are selecting them, that thing matters. So try to calculate in the similar way. Like the first object, it can be anything. So the first object can be selected in n ways. Okay. If you need to select R object, then the first can be selected in n ways. Second, now one object is selected. How many are remaining? N minus 1. So second object can be in any of the n minus 1 thing. So there are n minus 1 ways to select the second object. Now for the third object, you have how many objects are remaining? Two have already been selected. So how many are remaining? Two, n minus two are remaining. So for the third object, there are n minus two ways. Similarly, so on, you keep on doing this up to how many times? Until you get n minus r plus one. Okay. So this is called npr or n permutation r. Okay. So this is matlab there are n multiplied by n minus 1, so on you do for n minus 2 and up to n minus r plus 1. Okay. So this is also called like you can call it n factorial, means if you go by the formula, it is nothing but n factorial divided by n minus r factorial, because if you try to solve this, so you will get that you will get this term only. So this is also called npr. Okay, this n can be in the subscript, and this if you want, then this r can be in the superscript. So this is npr. So this is permutation. Now here it was the order was mattering, but suppose the order doesn't matter, then that will be called combination. So suppose the order doesn't matter. The question is same. There are n objects. You need to select any r of them, but the order doesn't matter. In any order you can select them. So order doesn't matter this time. Select any of the r objects. Select any r objects. So just the team matters. Just the group of objects matter. You can say that earlier we needed to select any particular sequence or order, but now in you need to just provide the r objects. Who are the r objects? Just you need to give them. So what would be the number of ways to do this? Try to answer. Try to answer. मतलब ये भी पता ही होगा. Hello. ओके, सो लेट मी टेल यू. तो इजी है, मतलब अगर एन ऑब्जेक्ट्स में से आर हमको हमको पता है कि अगर सिर्फ वी नीड टू सेलेक्ट एनी ऑर्डरिंग व्हेन ऑर्डर मैटर्स, द आंसर वाज n factorial divided by n minus r factorial this thing. But here the order doesn't matter, so it means that suppose we have selected the r objects in multiple orders, but we want to consider them as the same. So what we did earlier, whenever we had the whenever we need to arrange like n distinct people or n distinct objects, the number of ways to arrange them was n factorial. Suppose I have selected any ordering of the r people, so it can be any of the ways. In these ways I can select r people, but their means ordering can be different. Here order matters, so I need to consider all of them same. So those r people which I have selected can be arranged in r factorial ways, so I will divide my answer by r factorial. So you can say this thing would always also be divided by r factorial, multiplied by r factorial. Okay, so this is ncr, this was npr, and this is ncr. How this came? Just npr divided by r factorial, because those are people which I have selected can be arranged in r factorial ways, and I need to divide by that because here the order doesn't matter. So any ordering will work. Any ordering will be considered as one thing only. So I divided by r factorial. Okay. So this is combination, and now let us look at some of the properties which are useful. So let us say some of the properties are like first is simple ki ncr. Suppose you have ncr, so ncr will be always equal to nc n minus r. How this come? So simple hai. When you suppose there are n objects given to you, and suppose you selected r, so automatically the remaining objects are also selected in matlab, suppose you want to select r people out of n, so and in ncr ways you can select them, But when you have selected, when you have removed those r person, how many you are left with? You are left with n minus r people. So automatically you have selected n minus r people also. Okay. So in this way we can say that ncr is always equal to nc n minus r. Or one property is like ncr, which is useful to calculate ncr in competitive programming. So which is ncr equals n minus 1 cr minus 1 plus n minus 1 cr. This is also called Pascal's triangle property. Pascal's triangle property. तो ये भी कैसे आती है? Let us look how this is come. So you do not need to remember this. The simple way to like understand this is like, suppose there are n people and you need to select r out of them. Let us say there is one person called Jack. So any name you can give. Let us say there is one person called Jack in those n people. Okay. Now there are two cases. Either I will select that Jack or not. So let us say in the first case I select Jack. So if I am means I'm guaranteed that it is guaranteed that Jack will always be selected in my team of R people. So now Jack is already selected. How many people are remaining? There are n minus one people. And since Jack is already selected, you need to now select only r minus 1 people, because Jack is already selected. So you need to just select r minus 1 people. So this is the number of ways to select when Jack is already included. So either Jack will be there in team of r people or not. Okay. So the first case was that Jack is present in my r people team. So Jack is already present. So I need to select only r minus 1 people out of how many people? Since Jack is already selected, so I remove Jack. So now there are only n minus 1 people in my class. So I need to select only n minus out of n minus 1 people. I need to select only r minus 1 people. Fine. Now second case is if Jack is not present, guaranteed है कि Jack तो आएगा ही नहीं. तो फिर how many people are there in the class now? N minus 1, since I have removed Jack. But now since I need to select r people, so what are the number of ways to select r people? So it is n minus 1 cr. So from there this property is, you can say it is a simple proof. Okay. So either one person, you fix one person and let us say this person will be there or it will be not there. There are two ways. So here I have written or, means either this will be there or it will not be there. So I have written a plus between them. Why? Because some rule says that whenever you need to perform any one of the tasks, either A or B, then you do m plus n. In the total number of ways to do any one of them is m plus n. Fine. So if you have any doubt until now, you can just ask it so that it will be better for me to clear. Okay. Now one more important property is like, when you do ncr, so you can also write it as ncr can also be written as, or better say ki one, suppose this thing is there, 1 plus x to the power 1 plus x to the power 1 plus x to the power n. So this, if you expand this by binomial theorem, then you will get summation here. So it will be summation summation from r equal to 0 to r equal to n, and ncr will be there, or ncr multiplied by x to the power r. So let me increase the font size for this. So it is something like this. So ncr x to the power r, this summation you do. So this is the binomial expansion. So if you, Pascal's triangle property was the above one. So if you put x equal to 1 in the above equation, so what you will get, if you put x equal to 1 in the above equation, you will get 2 to the power n. So let me write in this way, that in the summation ncr, summation from r equal to 0 to n, ncr will be 2 to the power n. So this is one more important property. So you might have heard that there are total, you can say there are total 2 to the power n subsets of a set. So how this thing is coming? So in your subset, either you will select zero objects. It may be phi, it may be empty subset. So it's nc0, or you may select any one of them. So nc1. Selecting one object, it can be done in any one way. Selecting two objects can be done in nc2 ways. Similarly, you do summation from r equal to 0 to n, so you will get this thing 2 to the power n. So that can also be considered as a proof of that. So okay, this is 2 to the power n. 2 to the power n. Okay, so after this we have one more thing. NC, if you do like if you do NC 2NCN, 2NCN, so what it should be? Means if you write in the form of summation, you can also write it in this way. Summation 2NCN can be written as summation NCK whole square. NCK whole square, where uh, this NCK is means this k equal to 0 to n. Okay. So can you say how this can be proved, or any intuition for this? Anyone? 2NCN means what? There are 2n people. You need to select n out of them. So if you think of this like in this way, like there are 2n people, so you can divide them into two groups of n people each. So in each group there are n people. Okay. So divide 2n people into two groups of n people each. Okay, so each group is having now n people. Now from those n people, you need to select like from one group I selected, let us say k people. So from the second group I need to select n minus k people, because in total I need to select n people out of after both of these groups. So I can write the thing as LHS can also be written as like if you do summation from k equal to 0 to n, summation k equal to 0 to n, and nc nck multiplied by nc n minus k. How this has come? Because I divided these two n people into two groups, each of n people. From the first group of n people, I select, let us say, any k people. K can vary from 0 to n. So I am bound to select from the second group. I need to select n minus k people, because in total I need n people. So this is just like you can from this, you if you do this, so you know that nc are equal to nc n minus r. So these two things are equal, so you can write this also as nck. So it becomes nck whole square. So this is summation k equal to 0 to n nck whole square. So uh, sometimes means these can be like used sometimes indirectly, not means if you know how to just get an idea, means if you know how to prove this thing or something, that it might be useful in solving some of the problems. So I think these are sufficient properties which you might need. So like acha, one thing is ki how to compute ncr mod m. Ncr mod m. M can be anything, like m is not necessarily prime. M is not necessarily prime. Then how would you do it? You need to find ncr mod m. So but m is not prime here, not, it may be anything. So how would you compute it? see, you can apply this Pascal's triangle property. So like you can use dynamic programming, like say create a DP array of, let us say, 1000 by 1000, or let us say we take a variable max here equal to 1000, and let us say 1005, something like this, and we create an array of max to max here, and you create a recursive function for that, for like ncr, let us say. So int n, int r. It is dynamic programming, means like basically we will be using this property of ncr, which says ncr equals to n minus 1 cr minus 1 plus n minus 1 cr. So you can say that the answer would be simply return ncr of n minus 1 r plus ncr of n minus 1 r minus 1. But since you need to find some, let us say int m, some there variable is there m, which you need to find mod. So mod m you should return. Fine. Or one thing is, like if you already computed, you will store this in the dp array, dp of n r equal to this. And if this is already computed, so you are using dynamic programming, means you will compute one value at one time only. So there are total 10 to the power 3. This is 10 to the power 3 approximately. To 10 to the power 3 into 10 to the power 3 values are there total, which you will be computing. So you can say that each value will be computed once. So the time complexity, the number of operations which you will perform, will be 10 to the power 6, because there are 10 to the power 6 values in the array approximately. So if it is, and yes, all will be initialized to 1. Initialize all values to -1. Okay. In main, you can do this. So if it is not equal to -1, then I will simply return, means I have not equal to not equal to -1 means I have already computed it. So I will return directly. Return dp of nr. And base case should be ki when your r equals one case would be when r is greater than n. Although this would not be required, but still, suppose someone calls your function for ncr for r greater than n, so you would return 0. There are no ways to select r people if there are very less people. The number of people, total people are less, and you want to select more people, so it is not possible. So you return 0. And otherwise, what you do is if r equal to 0 or r equal to n, then return 1. So this is the base case. So using this, you can compute directly. But the thing is, this will work only when n and r both are of the order 10 to the power 3. But if suppose you have n greater than equal to 10 to the power 5, so this this would work only when n r both are less than equal to 10 to the power 3. So this method like will work. This is dynamic programming method. Or we use the Pascal's triangle property. So can anyone tell if what to do if n and r are both very large? Like let us say both are of the order 10 to the power 5. So how will you compute this ncr mod m? And let us say for simplicity now m is prime. Okay, now let us say m is prime. Let us say n and r are both now let us say 10 to the power 5 or 6. You can say for simplicity, let us say for now 10 to the power 5. So any idea how to compute? Now you cannot use this method because you need to create an array of 10 to the power 5 multiplied by 10 to the power 5. So 10 to the power 10. So such a big array you cannot create. Global array also you can create of, if you want to create an integer array, so you can create of maximum size of 10 to the power 6 or 10 to the power 7 values. But if n and r are both very large, so here you required a very large array for above method. So this will not work. Okay, so any other idea how to compute? Try to answer if you know it. You need to find ncr mod m, where m is prime number. Fermat's, you can use Fermat's theorem. So directly, मतलब you use this above formula for that. NCR का जो direct formula होता है ना, the definition is simply n factorial divided by n minus r factorial into r factorial. So you use this thing. तो क्या होगा? So uh, using this definition or directly this formula, we can compute it. So using this, so what will be NCR mod m? So NCR mod m will be n factorial mod m. Fine, but these the remaining two things are in division. So what you need to do is you need to find the inverses of both. So like you say, if you have the inverse of both of them, so if you do something like inverse of, let us say inverse of n minus 1 n minus r factorial multiplied by the inverse of n minus r factorial multiplied by inverse of r factorial. So something like this. So you need to find the inverse of this thing and inverse modulo inverse of this thing. Since m is prime, for finding inverse you use the Fermat's theorem. For finding inverse, uh, we can use Fermat's theorem. So Fermat's theorem क्या कहती है? Fermat's theorem says that if you need to find n inverse, so inverse of n mod m is nothing but n to the power m by 2 m minus 2 mod m. So this thing is in power. So using this, just for inverse of this, just we need to find this thing n to the power m minus 2, where m is prime. So this thing can be done in log of n, log of m. So time complexity would be log of m. Okay. So this is one more method. But suppose now this thing will also work when when your let us say n and r values are up to 10 to the power 6 or something like that. Sorry, when your m is you can say, since it what for this we need to compute the factorial. For this we need to compute the factorial modulus also. So you can say we need to pre-compute. If I am assuming that you have already pre-computed all the modulus of the factorial, so n factorial mod m is already pre-computed in one array. So we need to, for this method we need to pre-compute uh, modulo of like modulus of factorials of all numbers. How much? Let us say up to 10 to the power 5. So this thing will work only in this case. But suppose suppose n and m are very large. Let us say n is n and m are 10 to the power of the order 10 to the power 12, 10 to the power 16, something like this. So again, my question is how to compute NCR mod m. M is prime, but you, since for pre-computing you need to you need to create an array of the size n at least. So but now let us say ki, so you can say that so this method will work only when your n and m are approximately of the order 10 to the power 6 or something like this. Okay. This is approx, like it may work for 10 to the power 7 also, not sure, but of the order this. But suppose now n and m n and m are very large, let us say of the order 10 to the power 12 or something like this. Then any idea? Anyone knows how to compute this? Anyone? You need to find NCR modulo m, but now n and m are very large. Okay, m can be very small. Like m can be small, you can say, of the order 10 to the power 5, let us say. Sorry, NCR here n and r. I am talking about n and r are of the order 10 to the power 12, but m is very less. M is not very less, but of the order 10 to the power 5, let us say. Any idea for this? So, for such cases, there is one theorem which we will use, that is also called Lucas theorem. So, by Lucas theorem, you can say that whenever you need to find this NCR mod M, and let us say M is prime, so in that case, what you need to do is, let us say I find the value of n in base M. Base M means ki like similar to hexadecimal base, binary base, or when we convert one base to another. So suppose I write this value of n in some other base. So like uh, let us uh, write n and r in base M. So something like it will be n equals to something like some number of digits will be there. So let us say n k minus. Let me write in equation form. So it will be something like this. So n k minus one. Okay, n k minus one. Then there will be n k minus two. Then there will be n k minus three, and so on. So there will be many digits like this, and up to, you can say, there will be up to n0. So it will be something like this. There will be many digits in that modulo base M. And if I found this in this is in base M. So how to convert in any base? Just find like what we do for converting, for getting the binary of any number. What you do? Divide by two. Store the remainder, means just write the remainder, and again n divide by two. Whatever the quotient you got, for you recursively call that function. Means you recursively keep on doing this. Like if you know for binary, if you want to find the binary of, let us say, 9, what you do? 9. Let me erase this all. So for finding the binary of 9, what you do? 9 divide, because binary means base 2. So you divide 9 by 2. What remainder you got? You got remainder 1. So I write the remainder somewhere. Now 2 divided by 9 will give me what question it will give. So it will give me remainder will be 1 here, and it will give me question 4. So I will now divide 4. So 4 divided by 2 gives me remainder 0. So I will write remainder, let us say, here. And 2 divided by 4, the quotient is 2. So I will repeat the process for 2. For 2, you do the same thing. You get the remainder as 0. Okay. And what you get quotient as 1. So now you do the same thing for 1. So you will get remainder as 1. And you will stop the process here, because this quotient is less than this number. Okay, which is the base of the number. So finally you reverse the order of whatever remainders you got. So it will be 1001. I am reading from right to left. You reverse the order of remainders, so you get this thing. So you get 1001. So similarly, for any base, you can do first find the remainder, then whatever remainder you got, you means whatever the number was, you divide that by that number. The quotient you got, you repeat the same process for the quotient, and store the remainders like this. Means these remainders will be the digits in the base M when you write the number in base M. Fine. So if you do this thing for n, similarly you do this for r also. You write r also in base M. So, it will be something like r will be rk minus 1, rk minus 2, rk minus 1, rk minus 2, rk minus 3, and so on. Okay, up to r0. So now the thing is, by Lucas theorem, it says that now NCR modulo P you want to calculate. So it will be nothing but you just do NCR. You need to find NCR mod P. So NCR mod P mod M. Let us say M is our prime number. So mod M will be just you go digit by digit. First this digit multiplied by, means NCR, you do NCR of these two digits, and you multiply it by the NCR of these two digits, and so on. Like it will be I should say n k minus 1. Let me copy this. N k minus 1. N k minus 1. C r k minus 1. So I just took the NCR of these two digits. Now for the second digit, I'm doing the same thing. You take the NCR of these two digits. So you multiply them and do NCK minus 2, CRK minus 2, and so on. So this will give you the modulo. Means at every step, whenever you are multiplying, you take the modulo M. Modulo M. And similarly, you do keep on doing this. So similarly for NK minus 3 and so on. Okay, for NK minus 3, CRK minus 3, these are nothing but digits in whenever you write the number in base P. Okay, now I will write the code for this. So this was the Lucas theorem. Mod M, you need to do it every step. So and dot 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 I'm keeping. So you similarly do this up to N0 C0 up to the last digit. So this will work when your, let us say M is even when M is less than equal to 10 to the power 6, and when N and R are of the order even 10 to the power 18 also it would work. So the code is very easy to write. Like if you know how to compute the any number in base P, what you do remainder with P will be one digit and divide by P for the recursive function. So like it will be, I'm writing int NCR. You take N and R as argument and you take M as your prime number, which you want to means which you want to calculate mod with. Now, just one base case would be like if R equal to 0, then directly return. If R equal to 0, you return directly 1. Now, one thing is like when you calculate digits, when you calculate NCR of digits, and since M is very small of the order 10 to the power 5, so for this, for NCR of these digits, you can choose any method previously discussed. So you can use this method for computing the NCR of these digits. So don't worry about the digits thing, but you will be able to calculate the NCR of the whole number using this technique. So let us say that key one digit would be int I'd say digit of n would be n mod r, n mod m, and one digit of this r would be r mod m. Fine. Now what I need to do is I need to just return the answer for means NCR of these two digits. So I suppose I have one more NCR function, NCR of digits, or you can take NCR of digits. So it let me call it int and something it can be. I will not write the whole function. I will write key use any above method, like any method for NCR of digits as discussed above. Means Pascal's triangle, or you can use the inverse method, Pascal's triangle or modulo inverse method. So we have discussed both of these methods above. So you can use any one of them to compute for, because the digits are very small. When you write any number in base P, the digits will always be less than equal to P. So we have written the in base M. So the all the digits n k minus 1, r k minus 1, these all will be always less than this M. So, since you when you write in binary, always all the digits are less than 2, 0 or 1. Similarly, if it is valid for every base. So the digits will be small. So you can use any primitive method, any earlier discussed method for that, for NCR of that. Now I am not writing this function. You use any other method. Now we will call this above function NCR digits. For that, NCR digits for this digit of n, digit of r I will pass, and I will pass this m here. So we will do this, and after what we get, we need to multiply it with the remaining part. So the remaining part would be what? The remaining part would be, we will call this function recursively with the values as n by m, r by m, and what is the another thing? It is m. What, why I have done this? Because this is the quotient when you divide n by m. So this will be called for our recursive function because we are writing n and r in the base m. Okay. And modulo, at every step you need to take modulo m. So this will do your work. So I will give you one homework problem to try by yourself. So you can try that problem. So hacker earth, binary string. So Since you can see as in the problem that here x and y are very large of the order 10 to the power 16, but the modulo which you need to take is very of the order 10 to the power 6. So here you can apply Lucas theorem, because here if you apply the DP method to find NCR or any other method, you will fail. So just for practicing, practice this problem, means try this problem. Okay. So whenever you get time, try this problem. So we will discuss some more some other problems now. So uh, let us come to one problem for, like, suppose there are let us say there is a grid. So there is a large grid, and you can assume it in this way. Okay, it has some number of columns, some number of rows, like this. And you need you are at the you can say bottommost point, right? And at here you are at 0 comma 0, and you need to reach this point at the, let us say this is n comma m. So what would be the number of ways to reach if you can go only either to the right direction or above direction? In these two directions only you need to move, and you need to reach this place. So the problem is this one, key, you are at origin, okay, and you need to reach n comma m, but you can move only in two directions, either above, or you can say up or right. Okay. So if you know, try to answer. Means try to think in how many ways you can go from here to here. You are at this place and you need to go here. So one way could be like right, one right, 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 then up, up, up. This way, this is one way. One way could be right, right, up, right, something like this. There are many ways. So one way could be up, 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 right, 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 right. So this is one way. So how many, the total number of ways would be what? Anyone? Any idea? Try to answer if you know it, or means if you know how to calculate it. So one way is to use DP to if you use dynamic programming, means you can use this recurrence relation. So which Akhil has written, DP of nm equals to DP of m minus 1 cn, and c plus DP of m minus 1 n. Means basically the idea is if you are at this position, let us say x comma y, so you can reach only from this place or this place. Okay, so this the coordinate of this position is x minus 1 comma y, and coordinate of this is y minus 1 comma x you can say x minus, this is x minus 1 comma y, and this is x comma y minus 1. So deep the number of ways to reach this place plus the number of ways to reach this place, so it would be something like this. So this is one way, but suppose the n and m are very large, the dynamic programming method will can be used when n and m are of the order, let us say it can be used only when n and m multiplication of n and m is less than equal to 10 to the power 6 or 7. So the dynamic programming method can be used only in this case. But suppose n and m are very large, let us say n and m are or of the order 10 to the power 9. Take n and m, n both are 10 to the power 9. So this will give MLE. Dynamic programming you cannot use that time. So any other idea? So basically, if you think by the way of combinatorics, so if you see every path can be written in this way, like you want to reach this n comma m place. So in any case, you choose any path. So you always need to go, since this is n comma m means ki you need to go n times to the right, n times to the right, and m times above, m times up. So in every possible path, so you take any path in every possible path, you need to go n times right and m times up. ठीक है, I am denoting up by u and right by r. So like one path can be r up to n times, and then you go u up to m times. ठीक है. So and every path will be just a permutation of this. ठीक है. You draw any other path, like it can be first u all the u then all the r. But at every path, since you cannot go down, since you cannot go to the left, so it is you are bound to take this path. Means any permutation of this will work. So all the paths are just the permutations of this string r and n times and u m times. So just what will be the number of permutations of this string? So number of permutations of the above string. So number of ways. This is clear or not? Number of ways to reach the cell n comma m equals to just the permutation of this string, because every path can be written this way. Since you cannot go to the left or down, only you need to go up or right. So every path, like this path is there, right, up, right, up, right. So you find that summation of r will be always equal to, means you need to take you need to take n right steps in any case, and you always need to take exactly m up steps in any case, you if you want to reach this cell n comma m. So so our answer would be, yes, the answer would be simple. Since there are how many r's are there? There are n r's and there are m u's. So the number of ways to arrange this string is just n plus m factorial divided by since this r is same, so you will have n factorial and m factorial, right? So if you want to write in the form of this in the form of combination, so it will become n plus m cn. So it can also be written as n plus m cn. Fine, because if you apply the formula of combination, it becomes, if you consider this as capital N, and then what will be capital N minus small n? It will be m. So we have ncr equals to n factorial by r factorial into n minus r factorial. So this thing is same as this. If you write in the form of combination, so both are same. So you know how to compute n plus m cn. Suppose the answer in the question, it is asked to compute this thing modulo m, modulo some p, where p is some prime number. So you can compute it. Suppose n and m are of the order 10 to the power 9 or 10. Then also you can compute this thing. How? By Lucas theorem, you can compute the modulo if even if n and m are very large. Fine. So this will work. So this was one question. I hope it is clear. If it is not clear, then please mention what problem you are facing. Okay, so one question is that if m and n are greater than 10 to the power 9, would it give TLE? So it will not give TLE if you compute the means what you need to do, you need to find just this number and some NCR value, and you know how to compute the modulo of some NCR value. So the time complexity of this, I forgot to tell you, the time complexity of this Lucas method, time complexity of this Lucas method is O of log m. Why? Because if you are writing any number in base m, so always there will be you can say for every digit you need to go there. So there will be how many digits in that number. It depends on the number actually. So that the log n base m, something like this. The time complexity of Lucas theorem should be something like this. Okay, let me think. Uh, the space complexity would be obviously very less, because you do not need to have any extra space for anything except the you need to just compute for the and for all the digits you need to compute the factorials. For that you need some space, but if you see the time complexity, we are just going through all the digits of the number and of the given numbers of which you need to compute NCR. So the time complexity would be of the number of digits in base m of the number. So how many digits it can have at maximum is, it would be, yes, it would be log of the n and r. N and r, since r will be always smaller than n, so we can take log of n base m. That will be the number of digits, and for each digit, just we need to compute it. So you can write it as time complexity would be log of n base m. Okay, m is the base of log, multiplied by the time complexity of computing this NCR of digits. So this NCR, if you compute in O of 1 or O of log m, let us say, so it will be multiplied by it. So let us say we compute it in log m, so it will be multiplied by log m. It depends on this NCR digit function. If it is you are using Pascal's triangle, so it will be O of 1. So accordingly, so means into something. This thing would be always there, because if you are writing any number n in the base m, there will be always log n digits, log n base m digits. So the time complexity would be this. So you would not get TLE when n is, even when n is 10 to the power 18 also. Then also assuming that this, because this log will be always small, so you will not get TLE. Okay, so this is the time complexity of applying this Lucas theorem. I'm writing multiplied by the time complexity of whatever function you are writing for this thing, NCR digits. Okay? It depends on this time complexity also, the time complexity of NCR digits. I hope it is clear now. Any other difficulty if you are facing? Okay, so now just I modify this question. Like now you need to like let us say you have the same problem, but now you think in three-dimensional space. So just try to answer like what would be the answer when you need to reach some n comma m comma p, and you can move in three directions now, either up or right, or upright, or let us say forward. Means just in the positive direction of x-axis, y-axis, and z-axis. So and you need to reach this point. Just in three dimensional it is now. So what would be the number of ways? You are at origin means this. So this is the 3D version of the above problem. 3D version. कैन यू आंसर सिमिलरली कि पिछले बार जैसे ही कुछ आंसर पैटर्न मिलेगा तो ओके आई विल गिव यू 30 seconds or 1 minute. Try to think and write the answer. Anyone? It is just similar, like you need to reach this point and you can move in these three directions. So just what the string will look like if you want to reach this, so what your path will look like. So every means in every path you need to go to n times right, m times up, and let us say p times forward. So these are the three directions. So the string, like here also the similar thing will be there. So in every of the path you need to go n times right and u m times up, and let us say uh, how many times p times forward. So So u, then after that p times something like that. Sorry, p f forward के लिए लेते हैं तो p times f. So the string would be something like this. So just you need to find the permutations of this string. So the answer would be, permutations means total number of characters in this string is n plus m plus p, and that n plus n plus p factorial divided by n factorial, m factorial, and p factorial. This will be your answer. Okay, this will be your answer. And okay, so if you know multinomial coefficient, so you can also write in the form of that. So it will be like n plus m plus p comma n a m p, like multinomial coefficient में जैसे लिखते थे वैसे. तो वो मतलब कोई जरूरत नहीं रहती मल्टीनोमियल कोएफिशिएंट की ज्यादा, बस इससे समझ सकते हो, मतलब वही चीज है. ठीक है. और एक एक और वेरिएशन इसका देखते हैं जो बहुत काम आता है, मतलब कुछ क्वेश्चंस में. तो जैसे अगर 2D वर्जन पे ही देखते हैं. नाउ कंसीडर दिस वर्जन. नाउ बट यू कैन नॉट क्रॉस द डायगोनल. सो you need to reach n comma m. You can move in only two directions, but you cannot cross the diagonal. क्रॉस नहीं कर सकते मींस कि यू कैन टच द डायगोनल, यू कैन टच द डायगोनल, बट यू कांट कांट क्रॉस इट. ठीक है, मींस यू कैन नॉट गो टू द अदर साइड ऑफ द डायगोनल. सो दिस इज द कंडीशन. So you need to find the number of ways to reach n comma m such that you cannot cross the diagonal. So any idea about this? Try to write in chat if you have any idea. Okay, one hint I can give. Just the total number of paths you know to reach n comma m. Now you subtract the invalid paths. What are the invalid paths possible? So try to find how to count the invalid paths. Invalid paths are those which are just you can say crossing your border. And now let us say I simplify the problem. This problem is now for not for n comma m, but it is for n comma n. Means it is just you can say a square grid now from 0 0 to n n. Okay. I simplified this. Now just you have to reach this n comma n point, and you can move in two directions only, either up or right. But you cannot cross the diagonal. Okay. You can touch the diagonal, but you cannot cross it. So it is now a square grid. So like the diagonal would be something like this. So like one possible path is like if you go this up to this up to this. I told you you can touch the diagonal. So I am just touching it, but I am not going across. Means I am not going to the this part here. So some path like this. This is one possible path. Okay. One possible path is like this. You go here, you go here, you go here, you go here, like this. So all the possible paths, you will find that. Achha, anyone has any answer? जितने पहले निकाले थे उनमें डिवाइड बाय टू, मे बी नहीं, डिवाइड बाय टू से सारा नहीं मिलेगा। तो ओके, आई विल टेल यू द अप्रोच इज दैट कि इसमें क्या होगा कि when you observe all the paths, so it will be like this कि your path will contain, means your path, you know that your path contains n r's and n ups, ठीक है। तो it is just a permutation of n r's and n u's. So the number of total paths to reach n comma n, you know it. Okay, what is the total paths? It is just 2n, n plus n is n plus n equals to 2n. So 2n factorial, 2n factorial divided by, or you can say 2n cn. How this has come? We have already derived it. Means we have already just solved it for when we needed to reach n comma m. So you put m equal to n, so you will get 2n cn. Okay, 2n cn is the total number of paths. Now just there is one condition, you cannot cross the diagonal. So you find the invalid paths. Now invalid paths in which we cross the diagonal, we need to find them. So let us observe any pattern which we find in the invalid paths. So just try to observe any pattern. Now let us say I'm drawing an invalid path. So I go right, then I go up, then again let us say I go right, up, right, right, up, something like this. So I'm writing this pattern. What is it? Right, up. So it is right, up, R, up. Is it the same? 4 times up and 4 times R. I think this is the same. Right, up, right, up. Huh. So this is one path. Now just let me draw another path in some other color. Let us say, let me draw this path. Let us take it right, up, up, right, and up, right, something like this. So R, U. So it is R, U, R, U, R, and UR. It is like this. So similarly, you can draw many more paths. So main thing I want to tell you is ki now observe one pattern. Ki if you just find the first alphabet which crosses the diagonal. So if you do not want to cross the diagonal, it means that R should be greater than U at that moment. Okay, you can know it. Like if I have more R's, then I am always below the diagonal. But at the moment I have more up than the R. When like at this point I have more up, so you find there are 2R only and there are 4 up. 1 2 3, there are 3 ups, so I have more ups than rights. So whenever I at that point, whenever I have more U than R, that time I am above the diagonal. I am above the diagonal. Okay, so just find that point. So for these paths, find that point at which uh, we are above the diagonal, and reverse this path, means, and reflect this path, or we can say. So now I am just reflecting the whole path. So reflecting means like just convert R to U and U to R. So like it can be after reflection what this path will become. Now like you see in this particular point RUU, so I reached above the diagonal when I find the second U, because at this time R and U are equal. So when I was having these two alphabets, so R and U are equal, so I am just below or just touching the diagonal. But once I find one more U, so the number of U become more than the number of R, so I just reached above the diagonal. So since I reached above the diagonal, I need to just I'm observing one pattern, so I just reflect all the remaining, means I just Wherever there is r, I write it as u. So it will be u r r, something like this. So I am just reflecting this path. So let me use any other color. So I am reflecting this red path. So it will up to 3 points it will remain the same. So 1, 2, 3. Here it is remaining the same, but this r will convert to up. This r will convert to up. Okay, and since we have one more r, since there are three r's now, so it will be again up, and after that we have two right. So it will be one right, one more right. So we reach this cell. Okay, we wanted to reach n cross n comma n, but we reached somewhere here. So the coordinates of this place are, if you write it, n plus 1, uh, sorry, n minus 1 comma n. Okay, n minus 1 comma n plus 1. Is it correct? N minus 1 comma n plus 1. Sorry, I mean, I think I need to just reverse it from this point. Like, if we it from this point, like if we reverse it from this u, so this u should become r. So now I think it should be fine. So like this. So if you reverse it from this part, so it will become like, up whenever this touch the diagonal up till it is fine, but whenever it crosses the diagonal, you reverse it, so it becomes something like this. It is up, so I make it right. It is going right, so I go up, right up, I go it up, then in this way. So it should be, uh, like what the path is, r triple u r r. So r triple u r r. So I will reach at the same point. नहीं नहीं ऐसा नहीं होगा. Just give me 1 minute. So it should be like if I reflect it at this point only. So if I reflect it here only means यही वाला पॉइंट जहां से वो क्रॉस करे इसके बाद वाला ही. तो यहीं से हम रिफ्लेक्ट करते जैसे पहले किए थे. वन मीन्स दिस राइट विल बिकम अप अप up, then r something like this. So you will find that means, whenever you do this, you will, means if you do the same thing for this path, so at what point I'm crossing this diagonal at this point. So just from this point I will, you can say I will just reverse all the paths. So instead of going this about the about this place, so I will make it move, I will make it move above, means up to, instead of right I will make it move above. Or similarly here also we are going, here we are going to the right. So here we are going first above, so it will be right then above, something like this. So at every point you will reach this point only. Means I mean to say that कोई भी invalid path लोगे ना, उसको ऐसे reflect कर दोगे first u जहाँ पे मिल रहा है, जिस point पे u greater than r हो रहा है उसको reflect कर दो. उसके बाद से reflect means कि r को u बना दो, u को r बना दो. तो always you will reach this point. ठीक है. और ये point जो होगा, this point will always be, if you find it, this, our aim was to reach here, but we reached just this point, just which is just above and left of this. So you will always reach this particular point. So this should be, the coordinate of this should be, I think, n minus 1 comma n minus 1. Is it correct? Anyone wants to say anything? मतलब जब भी invalid path लोगे, so if you reflect it about at that point, so you will always reach this point. And one more thing, like, So you will reach some point here. So it will be, let us say, n minus 1 comma n minus 1. So basically you need to find the number of ways to reach this particular point. So I think I have done some mistake maybe, but uh, you can try this thing. Okay, I will just confirm this once, but means the when you will count all the, you may say all the invalid paths. So all the invalid paths would be like, it would be, you will get 2n c n plus 1. You will get this way only. Matlab, try to think of this ki when you reflect it, whenever you get the first u, so you will reach at one point. I'm not getting like, मुझे कुछ सही नहीं लग रहा है इसमें कि I have done some mistake maybe. So I will try to, maybe at the last I will try to correct it. So you will always get this number as 2n c n plus 1. So means these are all the invalid paths. ठीक है. So the total means you can say total paths which do not cross the diagonal would be this, the total paths to reach n comma n minus the invalid path. So it will be 2n cn minus this thing, 2n cn minus 2n cn plus 1. So from here you get some means this is some special number which is also called Catalan number. So if isko solve karoge to you will also get, you can also solve it, so it becomes ki 2n cn divided by n plus 1, 2n cn divided by n plus 1. Fine. So this is your Catalan number. This is also called Catalan number. So the speciality of Catalan number is that कि means Catalan number जब भी होगा तो Catalan number से we can have many of the things like Catalan number represent many things like for example you say the number of balanced parentheses of a string of length 2n. Okay, means you have balanced parenthesis means like it may be like this. The opening braces should be equal to the closing braces at every point. Means or means you can say like you at every prefix you can have more left parenthesis, but you cannot have right parenthesis. ठीक है, मतलब at you consider any prefix, so at any prefix you may have like if you consider a prefix of length 2, so you have more left parenthesis than the right one. There are two left but no right parenthesis. But you consider, if you consider a prefix of length 4, there are equal 0 0, means 2 minus 2 is 0, so they are balanced. But you consider a prefix of length 5, you get more left parenthesis than right. So at every point either the left parenthesis is equal or it is greater than the right number of right parentheses. And finally the total at the end when you reach, the total number of left parentheses should be equal to the number of right parentheses. Means it should be balanced. So such a string, the number of such a strings is also given by this number, is same as this thing. Okay, it is also equal to this thing. So example, you can consider this one also, and like if you consider this one also, there are many ways. So if you take n equal to 3, you will get you can solve and get only that there will be 6 possible or something like that only will be there possible balanced parenthesis for this. Similarly, there are many ways which you can many other problems in which you get this Catalan number is ki Catalan number. Someone told something for every diagonal point, if we add up the ways to reach the point just above the diagonal point, then sum the total number of ways crossing the diagonal. Okay, I will discuss it at the end. Okay, I will try to take मतलब देखूंगा कि क्या mistake हो गई थी, फिर I will tell what the approach should be. ठीक है, you can consider other examples like the number of possible binary trees of n nodes. How many binary trees of n nodes are possible? So if you try to find it, so it will also be equal to the Catalan number 2n cn by n plus 1. You can take example if you means I am not telling the proof because proof is just based on some things like principle of mathematical induction and these things. So just try to remember these whenever you face means somewhere it is asked तो binary trees कितने हो सकते हैं n nodes के. It is without labeling number of possible structures of binary tree. ठीक है, only if you consider the structure, I am not labeling the nodes, only I am considering the structure. So there can be such structure. I have some images for this. So like if you consider the number of binary trees of length, let us say 3, of of 3 nodes, so you will get these only possible structure for binary tree. Binary means ke each node can have only either 0 children or one means 2 children, like this, or 1 children means not more than that. Like this one is having only one child, this one is also having one child, like this. So you get only these possible structures are there. And similarly, this was an example for 3 example for n equal to 3. You get the below structures. If you try to draw more structure for n equal to 3, you cannot draw. All the structures that are possible will fall into one of these categories. Similarly, if someone asks you ki, what are the possible rooted trees for n nodes, number of rooted trees for n nodes. So the possible structures of rooted trees. So it will be n minus 1th Catalan number, n minus 1th Catalan number. So nth Catalan number is this. You know ki nth Catalan number is this. So just put n minus 1 in this equation. So I will say ki put n minus 1 means, or replace wherever there is n, replace n by n minus 1 in this equation. So you will get the number of possible structures of rooted trees. So for this also, let us say there are there, if we have n equal to 3, so these will be the possible structures which you will get for any rooted tree. Rooted means it is not necessary कि binary tree हो, बस एक root रहेगा. That root should be at the, you can say, at the top or somewhere, but that root will be fixed. But there can be any number of children for one node, like this has 3 children. So in this way, so you will get for any n, you will get n minus 1 Catalan number. This many structures are possible for any rooted tree. And okay, so this is one thing. Or apart from this, one thing is like if you have labeled nodes. So if you have मतलब total number of let us say total number of labeled trees of n nodes is n to the power n minus 2. ठीक है, when there are n nodes, so the total number of labeled nodes is n to the power n minus 2. Like you have for n equal to 4. अच्छा, this was for n equal to 4. ठीक है, for n equal to 4 these many possible structures are there. The above one was for n equal to 3. और लेबल ट्रीज का एग्जांपल देखना है, मतलब कि टोटल मतलब अगर हम सब लेबल को, सब नोड्स को लेबल दे दे 1 2 3 4 ऐसा, तो हाउ मेनी टोटल लेबलिंग्स, हाउ मेनी टोटल स्ट्रक्चर लेबलिंग व्हाटएवर यू सेड, और हाउ मेनी टोटल ट्रीज आर पॉसिबल. सो दैट विल बी n to the power n minus 2. जस्ट ट्राई टू रिमेंबर दिस, और कुछ नहीं हो सकता इसमें. ज्यादा यूज नहीं आएगा, लेकिन जस्ट यू शुड नो इट. ठीक है, नाउ लेट अस सॉल्व सम प्रॉब्लम. तो एक प्रॉब्लम देखते हैं. तो let us open this problem. Mm, 178D. I will send the link in chat. So it should be available. So I will also paste the link here. So you are given an integer s, and you need to find how many sequences are there whose in that sequence such that whose terms are all integers greater than equal to 3, and whose sum is equal to s. So the sum of all integers should be s, and all the integers should be greater than equal to 3. It is like this. So how many sequences are possible, and s is less than equal to 10 to the power 3, 2000. And since the answer is very large, you need to output the modulo 10 to the power 9 plus 7. So try to think of any approach. So just I will repeat the question once again. So you are given an integer s, and you need to find how many sequences are there such that the in that sequence all the terms should be greater than equal to 3, and whose sum should be equal to s. Okay, so before this, let us discuss one more problem. So, matlab, one just general problem like if you are given, if you need to distribute n candies, you can say n similar candies to you can say r people. In how many ways you can do it? Try to answer, or such that each person can get greater than equal to candy, get greater than equal to 0 candies. Means you can also frame this problem as something like this. Ki, in the equation, in the form of equation, you can write it as something like summation k equal to 0 to you can say means from we need to distribute to r people. So there will be, you can say, r variables, a1, a2, a3 up to ar, and summation of all of them should be equal to n, such that each variable can take greater than equal to 0 values. So it can be written as something like, let me take from I equals to 1 to r, we have something like a variable ai, the summation of which should be equal to n. And okay, let's say ki you are given n is less than equal to 10 to the power 6, and k is less than equal to 10 to the power 6, k or r, so it is 10 to the power 6, and output your answer modulo 10 to the power 9 plus 7. First try to solve this question. Output your answer modulo 10 to the power 9 plus 7. So you can write this as in the form of equation. In the form of equation, we can write it as like this. So in this thing, like if you have an equation like this where you can suppose it like you have a1 plus a2 plus a3 up to ar. There are r variables, and each variable can take where each ai can be greater than equal to 0. So each ai can be greater than equal to 0. Should be means you can say should be greater than equal to 0. So one person can be there who has not got any candy, and one person can be there who has got all the candy. It is also possible. So you need to find all the possible solutions. So any answer n plus r minus r plus n minus 1 c n. So it seems correct. So let us see how it is derived. So let us see how it comes. So just whenever you get such kind of problems, so acha, we cannot erase this for acha, let me. Okay, so first I will draw it later. I will first try to explain it. So we have, let us say, suppose we have some n candies. So I can draw candies as something like this, zeros kind of thing. ठीक है. तो instead of that we can simply take something like sticks. तो ठीक है. We have some candies. So let us say something like this. So we have some candies here. Now we need to distribute it to our people. So what I can do is consider r minus 1 sticks. So consider r minus 1 sticks or dividers, whatever you say. So I am drawing now dividers with a different color. So like I will say this is one divider. Anywhere I can place the second divider, and anywhere I can place it. May be like that. Two dividers are like this also. It is possible. So just for now, suppose there are some. Let us say how many sticks how many candies I have? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 candies are there. The blue color ones are candies. So I need to distribute among four people. Let us say. Uh, for now, let us say we have how many candies? 14 candies, and we are distributing to 4 people. So what I can do is कि जितने people है उससे एक कम stick बना लो. There are r people, so draw r minus 1 stick. There are 4 people, so draw 4 minus 1, 3 sticks. So 3 sticks or dividers I have drawn. So what it means कि the person A will take these many candies, the person B will take these many candies, C will take these many, and whatever remaining the D will take. So I have drawn, since I wanted to divide among 4 people A B C D, so I have taken only 3 sticks or 3 dividers. So like this. So just I need to find all the permutations of these sticks and these candies. So it can be something like this. So the total so number of ways is permutations of you can say here if we have 14 candies, and how many sticks we have? 3 sticks, because I wanted to divide among 4 people, so I have 3 sticks only. So means I want to just permutate it, means arrange it. So what are the number of ways to arrange these? Since these all candies are similar, these all sticks are similar, so the total number of objects are n plus r minus 1, since n are the number of candies and r minus 1 is the number of sticks. So if you write in the form of this thing, like 14 and 3, so it will be 14 factorial divide 14 plus 3 factorial divided by 14 factorial into 3 factorial, right? Something like this. So in a generalized way, if you write in general, number of ways would be n plus r minus 1. Why r minus 1? Because for r people we need r minus 1 sticks, and total objects will become n plus r minus 1. So I want to just uh, do its factorial divided by, since these n objects, these n candies are similar, so I divide by n factorial. So n factorial divide हो गया, और r minus 1 factorial भी divide हो गया, like this. So we have this as the total number of ways. Fine. So you can also write the same thing as n, like he wrote. You can, since by definition of combination we know that this thing is equal to n plus r minus 1 c r minus 1. Fine. So this is one thing. ऐसा भी लिख सकते हैं. So this is when you have an equation for r variables, each variable can take a value greater than equal to 0, whole number. So this thing will work. So this general formula, whenever you want to divide some values, or whenever you want to because this summation ai equal to n means you are dividing n things or n candies among r people. So this equation is same as this. Okay. So this is general way, this is general formula, you should remember it. So if you don't know it, if you know it, it's good. Otherwise try to remember it. It is used many times, like in the problem which we are discussing now is in this means you can also solve it using dp, but if the constraints are very large, you are bound to use this formula, otherwise you will not be able to solve. So Bharat, just I think I need to take 10-15 minutes more, 15 to 20 minutes more. You can you can join that link after that. Okay. So okay, so just this problem I will discuss the approach. Okay, I have already opened it. So someone has any idea how to solve it? ठीक है, हाँ, okay, he wrote. So in this thing also we are just wanting that our sum of all the numbers should be equal to s, but since all the numbers are greater than equal to 3, so you can say that if you try to reduce that thing to the above formula, matlab Acha, let us just is for is if we change this thing in the question, that suppose कि suppose you have something like this. If you need to distribute n similar candies to r people, but now one constraint is there, like person uh, each person can get greater than equal to, let us say, some c candies. It may be anything. Each person should get. So what will be your answer? Now I have just changed one more constraint. Like earlier, any person get zero can get zero candies also, but now each person should get at least c candies. You can say at least c candies. So what you would be your answer? If there are n candies, you need to distribute among r people such that all the r people, all of them get at least, each of them get at least c candies. So if you write the above in the above equation form, so you can say that each ai is greater than equal to c. So if you write this thing, so this thing where, so each ai is greater than equal to c. So I replace ai, you can take some variable bi. ठीक है, take bi equals to take bi equal to ai plus c, or you can say ai minus c. So if you replace bi means this thing in the above equation, so what you get is you get a similar equation with this thing, n minus you say r into c. How I will get this will be something like a1 plus c. Okay, so let me see once again. So it will be, since ai is greater than equal to c, I can write it as ai equals to c plus bi. Okay, so or you can say write it like this also. ठीक है, means you introduce one more variable which is bi equal to ai minus c for every like a1. For a1 you have b1 equal to a1 minus c, so that this new variable will always be greater than equal to 0. So now you have all bi should be greater than equal to 0. Bi should be greater than equal to 0 for all. ठीक है, this thing should be there, so that this summation will become equal to, if you do it, so it becomes n plus r into c. Is it right? Is this thing fine? Like everyone agrees this thing will be correct if you replace this in the above equation, because for every variable you will have, since there are r variables a1 a2 a3, for every variable you will have minus c term, so there will be total minus r into c. So if you take it to the RHS, you will get plus r into c. So this thing you will get. So the number of ways would be then this thing. Just we have derived it whenever this variable is greater than equal to 0. These are whole numbers greater than equal to 0, and we need to distribute some number of candies among them. These are people, so you know that ncr minus 1, ncr minus 1, something like this. So you just replace this thing in the above formula. So you will get, what you will get is, okay, what you will get is instead of n you write n plus r into c, this thing, n into r into c plus r minus 1, c r minus 1, because we need to distribute among r people only, but the sum has changed. We need to distribute now these many candies, so it is something like this, n plus r into c plus r minus 1. Okay, so the formula will be something like this. So is it fine? Now if you know these two things, I feel it is correct now. And this, or it should be something else. I think it should be subtracted, na? Is it correct? I feel it. I have done some mistake. Like AI should be greater than or equal to C. Each AI should get at least C values, C candies. So if we do Bi equal to AI minus Ci, AI minus C. Okay. Okay. So this thing will be. It should be minus because you will do something like AI will be equal to Bi plus C. So if, when it will go to that side, it will become minus. So sorry for this. So it should be minus sign here. Yes. Now it should be fine. N minus R into C plus R minus 1. Is it correct? ठीक है. Now it should be fine. Now is it correct? This thing should be your answer. Now for this question, what we need to do? Just the thing is key. We need to just make the sum equal to the given sum s, and we do not know the length of the sequence, so we can just run a loop. So it can be something like for each value of the length, you can run a loop for, let us say, for length equal to, because you do not know the length of the sequence, so it is in the question, it is not mentioned about anything about the length, but it has written key how many sequences are there such that all integers are greater than equal to 3 and whose sum is equal to s. So for each length we can find how many means how many sequences are there, and we can sum it up. So this will be something like for each length you will go length, and what can be the maximum length, since your each variable can be at least 3. So in the worst case all will be 3, something like that. So you will get length, maximum length is s by 3. So s by 3 will be the maximum length, and length plus plus, and for each length you do what your sum would be. Sum would be means sum would be s only, but this thing would be means which, or you can say directly, you can also write this formula also, you can directly use. So let us say we have total number of let us say we declare a variable answer here, int answer equal to 0, and just for every length you sum up the answer plus equals to answer plus equals to NCR of this thing. So what is n here? N is the total number of total sum. So the sum is s here. S minus the length is, since this r is the length. How many variables are there, or how many people are there whom you want to distribute among? So this will be the length, or a length into this constant c. This c will be, since we have taken at least each person should get at least c candy. So here each person should get at least value of 3. So here c equal to 3. So replace c by 3 here. Length into 3 uh, plus you get r minus 1. R minus 1 people means since here length is this len, so this will be the number of people. So this is r minus 1, something like this, or your this r minus 1, it will be len minus 1, because you want to distribute among this length number of people. So it should give you the answer. For every length you will sum this up. Okay. So this thing you will get it directly. Or इसमें one case can be when if this sum you are getting is less than 0. So in NCR function, when this n is less than 0, you return 0. That thing can be done. Like in NCR, when n greater whenever you write this NCR function of n cross r, so when n is n is less than 0, return 0, because it is, since n is negative, n should not be negative, it is outside the domain, so you return 0. Okay, so this will give you the answer. So this was just based on this type of, so many times you get this formula is used many times in, we will give some more problems. I will just paste the links here after the session, so just try to practice them. And just I want to discuss one more thing. Like you all might be knowing this thing, principle of inclusion exclusion, but for just I want to discuss it one time, like how you use it. Like suppose you have some, when you use it, like suppose you have two things like a and b, and you have the number of ways to perform a task A and perform a task B, but you have to find the either you need to find the number of ways to perform either task A or task B, but they have something in common. They are not independent. So that time you use this formula. A union B is A plus B minus A intersection B. Why this thing is there? Because since you have, when you are taking A plus B, the number of ways to do A plus number of ways to do to B, you have double counted this A intersection B. So you subtract it once. So you get this thing. So similarly, when you have three tasks or three ways, or you say three kind of sets. So if you need to find all the summation of all doing any one of them, so A union B union C, either of them, any of number of ways to do any one of them would be just you can say number of elements in the set A plus number of elements in B plus number of elements in C minus this thing A intersection B minus B intersection C minus A intersection B. Since minus we are doing because we have added these things two times. Okay. But whenever you do minus these three things, so you will see that you have subtracted this intersection means one extra time. So you need to add it up. So the formula becomes something like this. So I think you all might be knowing this. So just I am writing it directly. So you all know that why this is called inclusion exclusion principle. क्योंकि inclusion मतलब इसको include कर रहे हैं किसी element को, और exclusion मतलब नहीं ले रहे हैं. तो since whenever you are just finding A union B, so we are including A and B, but since we have double counted this intersection part, so we are excluding it. सिमिलरली इंक्लूजन एक्सक्लूजन का यही मतलब है कि कुछ चीज हम इंक्लूड करें लेकिन उसमें कुछ डबल काउंट हो गया, वो चीज एक्सक्लूड कर दी है, तो ऐसे करके. ठीक है. तो ये यूज कब होता है? इट इज यूज जनरली व्हेन it is used when we need to find means when you say when it is easy to find intersection of some offsets or anything intersection rather than union. So suppose that it is very easy to find this intersection, so you can directly find the union using these intersections. So in such kind of problems you will use this thing. So try to remember it. Or okay. So similarly you have something called derangements. So derangement means there are, let us say, if you have let us say you have n people who have n houses, and find the number of ways so that no person reaches his own house. So since all the people are having some house, like one person is having some fixed house, second person is having some fixed house, so you need to find the number of ways such that the person cannot reach his own house. So number of ways for this. So the number of ways would be you can find it using inclusion exclusion principle. Should be for that. Number of ways to find this thing is just suppose there is no such restriction. You just need to distribute these n people or arrange these n people for n houses. So you can arrange them in total ways is n factorial, but you subtract whatever are the ways, invalid ways, in which suppose we say let us say at least one person reaches his own house. So how many ways are there such that one person reaches his own house? So it will be nc1 into, since one person has already reached his house, so how many are remaining? N minus 1. So those n minus 1 people can be arranged in n minus 1 factorial ways. N minus 1 factorial ways. Okay. And similarly, it may be possible means in these ways we have double counted those ways where two people have reached their own house. Okay. So we will you can say we will subtract it. So what are the ways when at least two people have reached their own house? It will be nc2 into remaining people are n minus 2, so they can be arranged in n minus 2 factorial ways. Fine. Similarly, in these we have in these things we have double counted those where three people have reached their own house. So at least three people have reached their own house. We have double counted those, so we need to add it up. Like just we are following this principle of exclusion and inclusion. plus, then minus, then plus and minus, then and this so on. So we add those people nc3 into n minus 3 factorial, means at least 3 people have got their exactly their have reached their own house. So since each people is having only one house of their own, so we are arranging those people, okay? So in this way you go on up to, you will get it up to when this up to ncn. So it will be ncn will become 1 into n minus n factorial 0. So means up to that term you will go on. So this thing is also called dearrangements. Okay? You can also write in if you simplify this, you will get something like nc1 is n, so n multiplied by n minus 1 factorial, so it is n factorial, or you can write in n factorial by 1 factorial minus, if you do nc2, it will be n into n minus 1 divided by 2, and n into n minus 1 divided by 2, so it will be into n minus 2 factorial, so it will be n factorial divided by 2 factorial, and so on. So it will be for the third term it will be plus n factorial divided by 3 factorial. For the fourth term it will be n factorial divided by 4 factorial, and so on. So this is the formula for derangement. It can be similar thing, like it can have similar question like n, you want to send n letters to n mailboxes such that one letter is having a written it has written the address of one mailbox only. So the number of ways you need to find such that no letter reaches its destinated mailbox, something like that. So means such kind of problems are under the category dearrangement, so you can solve it using this formula. And if you know this how it is derived using the principle of inclusion exclusion, you can solve it directly. So now just I will discuss one or two small problems on probability, then I will hand over to Bharat. Okay, so let us consider this problem. Acha, for probability, there is nothing to discuss as such, but you should note that for probability that the formula is probability of an event E is the favorable outcomes divided by total outcomes. Favorable outcomes for event E divided by total outcomes. You all know this. So let us try to solve one problem. So you all know that in a deck of cards there are 52 cards. Means there are 52 cards in total. 13 of each category. 13 of spade. 13 of like what we call diamond or whatever. So you have a deck of cards. So you need to find probability of drawing 3 cards with the same value from a shuffled deck of cards. So anyone? What should be your answer? You need to draw 3 cards with the same value from a shuffled deck of cards. So what will be the total number of outcome? Total will be 52C3. Since after 52 cards you are selecting any 3 cards, so total outcome will be total ways or total outcome. Total ways or total outcome would be 52C3. Fine. And your favorable outcome would be try to answer if you know it. 52C3 is the total outcome. And how many are favorable? So for favorable outcome, just you select any one deck, like any one type of card, like either spade or diamond or something like that. And out of like you can say, you need to select cards with the same value from a shuffled deck of cards. So it will be something like you select a value out of 13 values, because there are a total 13 values. So you select first any of the 13 values, 13C1 multiplied by, now 13C1 13C1 means 13 ways to select any one value, and after that we have selected one value. Let us say like I've selected a value of 4. So there are 4 categories of in 4 categories in cards. Okay. So in those 4 categories, select any 3 categories. So that will be the number of ways. So it will be something like 4C3, because there are total four categories like spade, black heart, or whatever, heart, diamond, whatever. I don't know the names in English. So those were four categories. Out of that, you select any three categories. So four series, three ways for that, and you select any one value because all should have the same value. So it will be this. It will be this. So the probability would be this thing divided by this thing. So for probability, for finding probability, there are two ways actually. One is this using this formula, but sometimes it is easy to just go by the events. So this is method one. Or one more method is just you can say just simulate the events. Like if you just simulate the events, so first you will select any card. So since there is no restriction on the first card, so first card can be anything. So there is only means one. You can say it is not having any role in the probability. So you selected any one card. Let us say. So for that will be having a probability of one. So you need to select any one card. So it will be having a probability of one. So you will always select one card, and after that you have selected, let us say, one card. So you need, for the second card, you need a card with the same value. So like you selected the first card as with value 5, so the second card should also have the same value 5. So how many cards are remaining with the same value? So that from those many cards you select any one of them, and so it would be something like, since you have selected one card, it will be the remaining card will be 51, and out of those 51 you can select only since you have selected, let us say, a card with a value of 5. So how many cards are remaining with the value of 5? There are three cards more remaining with the same value, so it will be 3 by 51, right? And for the third card also you need to select the card with same value, and since you have selected two cards with the same value, so only two cards more will be remaining with the same value, so it will be 2 by 50. Why 50? Because now since you have selected two cards, so the remaining cards in the deck is 50 only. So this is also it. Both of these should give the same answer. You can try calculating, you should get the same answer. Okay. So this was one question, and one last question of probability, like, and why we are multiplying? Because it is just following the simple product rule which we discussed. In product rule, what is it? Give one by one whenever you are performing the event, one by one, and they are independent events. You multiply them. I forgot to write it. Independent events. Okay. Independent event or independent jobs, whatever you say. Similar rule applies for probability. Whenever they are independent events, you multiply them to get the total probability. So here, since these are independent events, first selecting the first card, then second card. So I'm doing it one by one. But like it is something like which is you can say I'm doing it these events one by one. So I can you multiply in such cases. So try to solve them. Means try to solve this one. You will get the final expression is this. Okay. Or one more thing is कि एक just one more question on probability, then I will hand over to Bharat. So you have 50 white balls and 50 black balls, and two boxes are given to you. Put them in ठीक है, to put all the balls in boxes such that it gives maximum probability to select a white ball. Means the thing is that you are selecting any ball out of any box, and the probability whichever you get of select the probability of selecting a white ball should be maximized. So you need to put the boxes you need to put the balls in boxes so that this probability is maximized. So how would you do it? Like means two boxes are initially empty, you can place any number of balls in any boxes such that whenever you are selecting a ball, you can select a ball from any of the box. So it is like there is no restriction on that, but you need to maximize that probability. So what would be your arrangement? So how many balls will you put in each box? Try to answer this. Means these balls are initially you have these balls initially and these two boxes are empty initially, so you need to put all the boxes in some of the box, like in some of the box you need to put all the balls such that it gives you the maximum probability to select a white ball. So the probability of selecting a white ball should be maximized. So what kind of how many balls in which box you will put? If you put all white in one box, so okay, one way is this. So someone is told, so let us try all the possibilities, whatever are the possibilities we have. So one way, like if we put all white all white wall in one box and all, so if you put all white balls in one box, then definitely you need to put all the black boxes in the second box, because you need to put all the balls in some of the box. So and all the black balls in second box. So total number of then the probability. So in this case, probability of picking a white ball is, what will be the probability? Since 1 by 2 for selecting the box, 1 by 2 multiplied by 1 by 2 multiplied by, if there are all the white balls in one box, so it will be 1 plus in the second box, probability of selecting the box, second box, because there are two boxes, so any box can be selected. So half probability for this box, half probability for this box. So half into 1 for in the box which we have all the white balls, and second for the second box. So in the second box there is no white ball, so it will be 0. So you will get the probability as half only. So the question is now कि can you increase the probability more than half? 0.5 से probability बढ़ा सकते हैं क्या? So try some more cases कि और क्या कर सकते हैं. So all white in one box gives me the probability of 1 by 2. Now my question is, can I maximize this probability even more? So just just try this thing. If we put only one white ball, मीन्स यू आर क्लोज टू द आंसर. यू थॉट कि मैं एक बॉक्स में सारा व्हाइट डाल दूंगा तो मेरा उस बॉक्स से व्हाइट निकालने का प्रोबेबिलिटी तो बढ़ जाएगा. सही है, लेकिन ऐसा सोचो ना कि सारे के सारे व्हाइट उस बॉक्स में क्यों डाले. मतलब एक ही व्हाइट अगर तुम उस बॉक्स में डाल दोगे तो तुम्हारा प्रोबेबिलिटी व्हाइट बॉल निकालने का ऑटोमेटिकली 1 हो ही रहा है ना. तो सिर्फ एक ही व्हाइट बॉल डालो एक बॉक्स में, ठीक है. तो इफ यू पुट ओनली वन व्हाइट बॉल इन वन बॉक्स एंड all remaining you can say 49 white balls and 50 black balls in box 2 in, ठीक है. तो that time probability of getting one white ball would be what? The probability of picking one white ball would becomes half into 1, because in one box, in the first box only one white ball is there. So definitely if we go to the first box we will get a white ball. So half into 1 plus half for the second box, half into 49 by 50. Now I maximize the probability for the second box. ठीक है. So this thing 49 by not 50, it will be total balls on 99, 49 by 99. Yes, because in the second box there are 50 plus 49, total 99 balls. So this will be your answer. So this is the maximum probability. So this is not half but more than half plus this thing. You can say 49 by 196, 198 plus half. ठीक है, this thing you get. So this is the maximum probability. This is the maximum probability. Fine. So if you have any questions, you can ask in the chat. So now Bharat, you can join that link. So I will allow you to screen share. One box and one whiteboard. Bharat, please join this link so that. Just wait a minute. Here, he will join in a few minutes. Till that, if you have any doubt, you can ask. However, you can share your screen.
Okay. It is visible, right?
Yes, it is visible.
So probability is done. So next we'll go to expected values. Expected values. So expected value basically means E of expected value. Expected value basically means the you are performing some experiment, and which is the value that you are most likely to get. This is the basic idea behind expected value. The value that is most likely to occur in an experiment. Experiment means here random experiment. So if we take it as mathematically, let's say you have a sample space that is having S1, S2, and so on till Sn events, and expected value of this sample space will be equal to, and sometimes these events will not be numbers, so for that we have to associate a value. That value we'll call as random variable. This random variable is x, so x of s1 will be some integer x1. Instead of 1, let's take some other value I. So expected value of this random variable will now be equal to summation of uh, probability of event si times xi. This xi is basically the value associated with this event for every I. So this is the basic mathematical definition, and I think most of you know this already. And so we'll start with a basic problem. Uh, you are rolling a six-sided dice. What will be the expected value? So you can try this problem based on this equation. So here your values will be 1, 2, 3, 4, 5, and 6. And what will be the expected value of this? You can type in chat. Why is no one typing anything? 3.05. Okay. Yeah, exactly. So for everything, the probability is going to be 1 by 6. Probability of getting any number is going to be 1 by 6. So answer will be 1 by 6 into 1 plus 1 by 6 into 2 and so on. So we'll take this 1 by 6 common outside, and let's write this 1 plus 2 plus 3 plus 4 plus 5 plus 6. This will be your expected value, and this will be 6 into 7 by 2 by 6 equal to 21 by 6. Be 3.5. Okay, I hope this is clear to everyone. So let's go to the next problem. So basically, first we are solving some basic problems by hand, then we'll go to CP point of view. Let's take the same problem and change it a little bit. So rolling a six-sided dice twice, and your score will be maximum value that you get in the two turns. So in this case, what will be the maximum value? So what will be the expected value that you will get? The question is clear, right, to everyone? Or is there any doubt in the question? 1 by 36 into 2 plus 3 plus 4. I don't think so. That is correct. So first we'll find this P of I equal to the probability that I is the maximum of two numbers. What will be P of I? Okay, since time is less, I'll just proceed with this. Probability that I is the maximum of two numbers. Now every turn we can represent like this, a pair of numbers I comma j, and obviously uh, one of the values. So first every turn we can represent as I comma j, and for I to be the maximum of two numbers, j should be greater than or equal to, sorry, j should be less than or equal to I for I to be the greater element. j should be less than or equal to I. Let's consider this case 1, that is j equal to I case. This case there is exactly one value, one way, and case 2, that will be j is less than I. This will be 2 times I minus 1, because I comma j and j comma I both are different. This will be, so totally p of I will be equal to number of favorable outcomes, that will be 2 into I minus 1 plus 1. This you can write it as directly 2 into I minus 1 divided by total number of outcomes is 36. So our expected value, that will be equal to summation of 2 into I minus 1 by 36 into I. If you take 36 outside, it will be 1 by 36 into summation of 2 into I square minus I. If you simplify this, what would be the answer? 1 by 36 into 2 into sum of first 6 squares. It will be 6 into 7 into 13 by 6. Should be 7 into 13. 13 minus sum of first 10 natural numbers. First 6 natural numbers, that will be 21. And just simplify this, then you will get the answer. Or I'll just do this. 1 by 36 into so this will be your answer. Is this part clear to everyone? The second question. If you have any doubt, just type in the chat. I will see. So I hope there is no doubt till now. So then we'll move to the next problem. Uh, so the problem is you are given a sequence of n distinct numbers, and we have to choose one of the 2 power n minus 1 non-empty subsets uniformly at random. Uniformly at random means the probability of choosing any of the non-empty subsets is same. It doesn't matter which subset you choose, everything has same probability. Find the expected value of the difference between maximum and minimum element in the subset. If you have any doubt, not just type in the chat, because I don't know whether you're understanding or not, especially the second problem. This is sort of basic, and most of the times you'll be doing like this only. So no doubts. Okay, so is the question clear? If the question is clear, just type something in the chat whether the question is clear or not. Question is clear. Okay, then think for 5 minutes, maximum 5 or 10 minutes. I'll give the solution at 4:30. Doubt in second question. Summation 2y square minus I. Okay. So first what I'm doing is I'm calculating the probability that I is the maximum of two numbers. And if you see the every time we'll get two numbers, I comma j. That I'm representing as I comma j, these two numbers. And for I to be the greatest element, uh, first I'm taking two cases. One is j equal to I. There is exactly one way that is possible. And the next case is j is less than I. There will be 2 into I minus 1 ways because uh, I comma j and j comma I both are different. So for that case I'm multiplying by 2. And probability is the favorable outcomes, that will be 2 into I minus 1 divided by total number of outcomes, that is 36. And next is expected value. Expected value is probability of the event times the value associated with it. So probability we have just calculated as 2 into I minus 1 by 36 times I, and this I am just multiplying inside, so that will become 2 into I square minus I. Then after that it is just summation. Is it clear now? So I equal to 1 to 6, just mentioning, I thought it was obvious. Okay, so I think I'll give the solution. In this particular problem, if we uh, approach the problem similar to the previous two problems, that is a probability that maximum minus min value is something and times maximum minus min value, that is as per the definition, then it is very difficult to say the answer. So for this, what we'll do is we will find the contribution given by each element. So for example, let's so first before this, for simplicity, let's sort the given array, and after sorting, the array becomes something like this: a0, sorry, a1, a2, so on, ai, and so on till an. This will be your array after sorting. And let's take some element. Let's consider an element ai. So what will be the contribution of ai? If you look up at the contribution of ai, if in some subset here refers to non-empty subsets, okay? So in some non-empty subset, ai is the maximum element, then its contribution will be minus ai, that is contribution to the sum will be minus ai. And similarly, if in some non-empty subset, if it is the minimum element, oh sorry, maximum element means it will be plus ai. And in some subsets, if it is the minimum element, then its contribution will be minus ai. So now our problem reduces to uh, finding the probability that ai is the maximum element in some chosen subset. Probability that a is the maximum element in some chosen subset or minimum. So first, let's consider a probability that ai is the maximum element in some chosen subset. And for this to be the maximum, we have to only consider for ai to be the maximum element, any element with index less than I can be chosen in the subset. And what is the number of such subsets? That will be exactly 2 power I minus 1. And similarly, for p min, and this is the number of occurrences. This we have to divide by the total number of non-empty subsets, that will be 2 power n minus 1. And similarly here, number of subsets where p ai is the minimum element. In that case, any element with index greater than I can be chosen in the subset. And number of such subsets will be 2 power total n elements, and other than the first I elements, any element will be greater than this ai. So this will be 2 power n minus I divided by 2 power n minus 1. And so for the answer, what we'll do is for int I equal to 1 less than equal to an I plus plus, to the answer we'll add this value into a of I, and to the answer we'll subtract this value. So just don't worry about the overflow and all. The idea is just to teach the concept, not thinking about overflows and all. So if you have any doubt in this, you can ask specifically from at which point you have doubt. How do you write any element with index greater than I or less than I in the two cases? No, so first we are considering the contribution of the element, right? So in some chosen subset, if A is the minimum element, then we'll subtract AI. And for that, we have to know the number of subsets where AI is the maximum or minimum element. Since we sorted here already, A1 to AN, any element with index less than I, that will be smaller than AI. And any element with index greater than I, that will be bigger than AI, because every element is distinct according to the problem. Is it clear or? Okay. So any other doubt, you can also uh, point at which point you're having doubt. Because this trick is very commonly used. Contribution to the answer. Okay, I'll wait for 2 more minutes. If you have any doubts, you can ask. Otherwise, I'll go for the next problem. Meanwhile, I write the next question. You are given beads of m colors. Colors, and for each color, for each color, there are infinite number of beads, and you have to make a necklace using these beads. Find the expected number of distinct colors in the necklace. So if the question is clear, just type something in the chat, or if it's unclear, put it away. Infinite number of beads for each color. make a necklace of n beads. Sorry. So basically you're given uh, m colors of beads, and using those beads you have to make a necklace. And what will be the expected number of distinct colors in this necklace? So for example, m equal to 3 and n equal to 3. Suppose if your necklace has 1 comma 2 comma 3, then it is having 3 distinct colors. Like that you have to find for all possible combinations and check. Just type something in the chat whether the question is clear or not. So think for 5 minutes. I'll tell the answer after 5 minutes. You have infinite number of beads, but the necklace consists of only n beads, right? Particular number of beads of a color. So infinite number of beads basically means your chance of taking any color is equal. So, okay, then I'll just reframe the question a little bit. There are infinite number of beads of each color. I think question is fine only. So infinite number of beads basically means, suppose you take some bead. Suppose for example at some point you take a bead of color 1. Uh, the next time the probability of taking that color 1, that will not change. That is the basic idea behind infinity. Meaning every time you are choosing a color I, that will be independent. No, this will not be the same if we have, no, if we had n beads means every time the probability will change, right? So for example, the first time you're taking, the probability will be 1 by n, and after that the second time it will be 1 by n minus 1, like that. Okay. power n minus m minus 1 power n by m power n minus 1 m power n minus 1. Yeah, that is correct. The answer given by Bhavesh, that is correct. So then I'll explain the solution now. So for this problem, what we'll do is, again we'll try to find the contribution for each element. So let P of I equal to probability that color I is chosen. And what will be the value associated with this xi? This will be 0 if color I is not chosen, and 1 if color I is chosen. So now the problem actually reduces to this. 0, multiplying anything with 0 is going to give us 0. So problem is now reduced to expected value of x is equal to summation of P of I. And by this definition, this infinite number of bits, we know that P of I equal to same for all I. Everything is equally likely to occur. So E of x reduces to, or E of x is equal to m into P of I. Now to calculate P of I, probability that color I is chosen. Oh sorry, this is not I is chosen. Probability that color I is present in the necklace. And not present. So probability that color I is present. Color I is present means it occurs at least once. So this P of I we can easily write like this: m into 1 minus P dash of I. That is probability that color I is not chosen even once. So what will that be? P dash of I, that will be equal to, for all the n positions we have to choose any color other than color I. Total we have m colors. So except this one element, we can choose any of those m minus 1 colors n times. This will be the number of favorable outcomes divided by m power n. So this will be your P dash of I. So E of x will be now equal to m into 1 minus this big expression here. And if you simplify this, you will get the expression given by Bhavish in the chat. So again, if you have any doubt, just specify that. I'll explain one more time. This is probability that color I is not present. Okay, is this clear for everyone then? I don't think so. If there is any doubt, no, please ask in chat because next problem will be difficult. This is sort of basic thing, classical problem. If you have any doubt, just type in chat. I'll explain one more time. Okay, so then I'll go to the next problem. Uh, Next problem is you are given a random number generator that generates an integer from 1 to n uniformly random, uniformly at random. And uh, find the at each turn. So basically at every turn it will generate some random number. You have to find the expected number of turns needed to needed such that k distinct elements have been generated. And let k less than or equal to 10 power 5. Or just I'll reframe this in a easier to understand way. It will stop generating once k distinct elements have been generated. Find the expected number of turns. This problem was asked in coordination coding ground actually. So if you have any if the question is clear or not, just type it in the chat whether the question is clear or not. just type in the chat whether it is clear or not. So I'll give you 10 minutes for this problem. I'll give the answer at 5:10. Okay, this is actually a difficult problem, so I'll give the solution now. So earlier, whatever we have done, all those things were based on the formula that I discussed earlier. uh, Expected values, probability times that value, summation of that. Here, let's take a different approach. Here, basically we'll use dynamic programming, and state will be dp of I equal to expected number of turns needed to reach k distinct elements such that we have I distinct elements with us. Or right now we have I distinct elements right now. So what will be the base case? So if you have understood the state, then you can say this. What will be the value of dp of k? Type in the chat. Or is the dp state unclear to you? That also you can type in the chat. I'll explain one more time. Why is no one replying? Okay, exactly. dp of k will be equal to 0 because we don't need any extra steps after that. We don't need any extra turns. Once we have k distinct elements. Now let's see the transition, and our answer will be dp of 0. So initially we have 0 distinct elements, and we have to find the number of moves needed to reach k distinct elements. I mean expected number of moves. So let's see the transition. Suppose current state is dp of I. Then case 1. The chosen element is from one of the I distinct elements already chosen. Then in this case we will again move to this dp of I state. And next is case 2. The chosen element is not from the I distinct elements already chosen. Then in this case we will move to dp of I plus 1. So basically what I mean is dp of I will be equal to 1 plus, because we have to make one extra move anyway, into dp of I into the probability of this happening is 1 by I. Sorry. Probability of this happening is I by n into plus sorry plus n minus I, that is not these I elements, by n into dp of I plus 1, because once you chose this element, uh, none of the element from the I distinct elements, we will have one more distinct elements, so that will be I plus 1. And if you solve this recurrence, okay, just solve this recurrence and tell me what will be the answer. dp of I into 1 minus I by n equal to n minus I by n into dp of I plus 1. This again we can reduce n minus I by n plus 1. Let's write this as n by n instead. Now if you remove this n by denominator n, then dp of I will become equal to dp of I plus 1 plus n by n minus I think so. I'll just write it one more time and check. Yeah, it's correct. dp of I equal to dp of I plus 1 plus n by n minus I, and this you can calculate in order of k time complexity. So again, if you have any doubts anywhere in this expected value, you can type in chat. This is not an easy problem definitely, because actually there is another way. Instead of using dp of I and the transition to I plus 1, we can transition to dp of I from I minus 1. But that dynamic programming will be very difficult. I mean, you can try it yourself, you will get something like an AGP, arithmetico geometric progression, and it will be very difficult to solve. But if you use this method, you will get this nice recursion, dp of I equal to dp of I plus 1 plus n by n minus I. I hope it is clear. If you have any doubt, you can ask.
Okay, so If it is over, then just I want to just make one correction, which I told I will discuss it last.
Okay.
So, okay, just I am sharing my screen. Okay, so just what I told was ki if we want to reach this place n comma n from 0 comma 0, let us consider any invalid path. So I'm just discussing that thing again. So we want to our aim is to find out how many paths are possible if we want to reach n comma n from 0 comma 0. Okay, I hope I'm audible. ठीक है तो हाँ तो this was our question कि we do not need to cross the diagonal मतलब we need to find all such paths such that we need to reach this place n comma n from 0 comma 0 and we can move only in two direction either up or right or but you cannot cross the diagonal. You can touch the diagonal but you cannot cross it. So just first we know the total number of paths will be always 2n total number of paths to reach this n comma n. But we will just subtract the invalid paths from that. So what are the invalid paths? So invalid path, one of the invalid path is this, like this, R U U R triple R U U. So this I have drawn R U U triple R U U. So this reaches n comma n. So this is an invalid path because it just crosses the diagonal. It is not touching, but it is also crossing it to one point above. So what is the indication that it is crossing? Whenever you will find that at some prefix, the number of u is more than the number of r, it means that it is crossing the diagonal. So okay, this is one invalid path. So just for every invalid path, we can do one thing, that at that point when it is just above the diagonal, it's fine up till now, but after this point just reverse everything. Reverse means this right will become up, so it will be this. From now this again one more right is there, so it will become up, so up will become right and right will become up. So from this point start reversing all the things. So this again, this right will become up like this. Now this up will become right like this again, this up will become right. So you will reach this at this cell always, which is whose coordinates are, you can see, since the you can say the row number is n minus 1 and column number is n plus 1, or x coordinate n minus 1 and y coordinate is n plus 1, something like this. So we will always end up reaching at n minus 1 comma n plus 1. Okay, so you can do it for any other path. Like let me take any other example. So like apart from this, if I had my original path is this, so I have written this thing here also, like find the first point which is about the diagonal and just from that reverse the direction. So u will become r and r will become u. So if you do this, so you will always end up at this position n minus 1 comma n plus 1. And n minus 1 comma n plus 1 means that you need n minus 1 r's and n plus 1 u's. So number of u will be more and number of r will be less, something like this. So the total permutation of this path will be, since if you sum up these, you will get n plus 1 plus n minus 1 will be 2n. 2n c n plus 1. You will find this. Because total permutation will be n plus 1 plus n minus 1 whole factorial divided by n plus 1 factorial divided n minus 1 factorial. So it will be equivalent to this thing. You can try with this path also. Let me try with this path. So r r triple u r u r. So if I draw this path, this is my invalid path, r r triple u. So see, r r triple u means the number of u is 3 and number of r is 2. So at this prefix, the number of u is more. So it means it is definitely an invalid path. r r triple u r u r. R U R. This is my invalid path because it is crossing the diagonal. I don't want to count this path. So for every invalid path, I told you just what you do at that point when it is just first time reaching above the diagonal. At this point, just reverse all the things. Means R will become U and U will become R. Or you can say this right will become up, and this after this right, this up will become right, and again this right will become up. So I have written also this in the form of string. So in this form of string, if I write this, so it would be something like, up till this point it will be same because it is just crossing the diagonal at this point. So up till this it will be same. From the next point I will just reverse it. R will become U, U will become R, and R will become U. So this second path becomes this. Just I am doing this for every path. So you will find this also ends up reaching at this position, at this coordinate n minus 1 comma n plus 1. So you will find that every invalid path can be written as the number of ways to reach this position n minus 1 comma n plus 1. So the number of ways for this is, I already told you that it is at 2 and cn plus 1. So that is why the total number of paths which do not cross the diagonal will be equivalent to this. And these are also called Dyck paths. Okay. So this is just a name, Dyck paths. So this is the formula for that, and this is equivalent to Catalan number. This I told you. And similar thing is valid for if you think in the term of bracket also now. So for bracket also you think that for every invalid parenthesis and for every invalid balanced parenthesis which are not balanced, you will find that one prefix will contain one extra right bracket. So from that right bracket, you try to reverse all the remaining brackets and you will find a similar pattern there. So you will find that similar number of permutations can be formed and you can derive a similar thing for brackets also. So for bracket also this thing be equivalent to 2 and cn plus 1. So this is Catalan number. Okay, one thing was this, and some practice question I want to give you for combination. So this is one good question which was asked in Google Kickstart. So I will send the link in live chat also. You try it by yourself. Acha, okay. So just I will just give the practice questions. So this is these 2 3 questions are there. So one is this one. So in this problem, just I will just explain you the statement in short. So the problem is something like that: a grid is given to you, and you need to reach this n comma n from 0 comma 0. But there is a some rectangular hole, you can say. So there is some hole like this. You cannot reach this place. Okay, something like this. And you can say that you need to find the probability that the person starts from here and reaches this point without falling into this hole. He doesn't move into this hole anytime. So this was asked in Google Kickstart round C, I think. So I will share the link. So you try to solve it by yourself, but the problem is that if you try to solve it by using dynamic programming, then only test case one you will be able to solve, in which the constraints are very less, where this height and width of the rectangle is less than equal to 300. This will be, you will be able to solve using dynamic programming, but this test case two, if you think, so you need to think of combinatorics, then only you will be able to solve. So try to think of your own. But just one hint I will give, ki if you are facing like difficulty for overflow, because NCR value would be very large, and here you do not need to find the mod of NCR. Here you need to find the probability. So basically, the values will be very large. So just try to find the logarithm of NCR or logarithm of the factorials. Okay, so because the logarithm will be very small value, so it will not overflow, and you will get accurate result, you can say. So in terms of logarithm, if you try to solve it, you will be able to do. So try to practice it. So I will just share the link. Some practice questions. So one is this one. And one is this one. See this one. Try to solve it by your own. And one more problem is, sometimes in problems of dynamic programming, you will find that sometimes means in problems of means which will be combinatorics, dynamic programming can be used, because dynamic programming can always be used in such type of problems. In most of the times you can solve by dynamic programming. So try to solve by any one of them, either combinatorics or dynamic programming. So these 4 problems I wanted to give. Now I will just hand over to Bharat. And this Dyck path is clear or not? You can write it like if you understood it or not. Okay. Okay. So Bharat, you can share your screen now.
Okay. Okay, I think the screen is visible. So let's see. So first the DP state. State is you are having I distinct elements. What is the expected number of turns you need extra? How many more turns you need to reach k distinct elements? That will be your DP state. That is expected number of turns, expected number of, let's say, extra turns needed to reach k distinct elements, such that we have I distinct elements right now. So obviously the base case is dp of k will be 0, because once you have k distinct elements, you don't need any extra step. That will be 0. And for the transition, so if you are having, if you're choosing one of these I distinct elements, so this is just, I'm taking some random I elements, so 1 2 till I, some I elements, and these elements have been chosen. Now if you take any one of these elements, 1 or 2 or any of these I elements, then you will still need dp of I, this many number of extra steps, right? That is definitely you have to perform one more extra step. That is, once you have I elements, I distinct elements, you have to choose one element, and that element, after choosing that element, if it is one of these I elements, then you will still need these many extra steps, dp of I number of extra steps. And if you don't choose these I elements and you have chosen some other new element, then in that case you will have I plus 1 distinct elements. And once you have I plus 1 distinct elements, this will be the probability of choosing that. That is any number other than these I elements. And after that, it is just simplify. This type of DP may be new to you, because I think till now you have seen DP transition from one state to another, not from state to the same state. And this type of transition will not always have a solution. It will have a solution only when this n minus I, where is that? This n minus I, only if it is non-zero, it will have a solution. So just keep that in mind. So is that clear now? Treat expected value just like that, in the literal sense. Don't think about the mathematical values. Is it clear, Bhavesh? Or anyone who has doubt? Or if you have any doubt, no, just specify which part exactly. Okay. Then if anyone else is having any doubt, just specify that part. I'll clear. Otherwise, I'll close. Why do we need to add one? Because you are having I distinct elements, and what at each turn, what will you do? You have to add one turn, right? Suppose say you are having, suppose, 0 elements initially. Then what will be the transition from 0? You have to do one. You have to perform a move. After one turn, where will you go? This will be your transition. Is that clear? No, actually, this problem, no, it was asked in coordination coding ground, and it was not even our college. It was some other college coding ground. So that's why I didn't give the link. I only have the image. If you want, I'll just paste that image here. Okay. If you have any doubts, ask. Otherwise, I'll close the stream. So I also have only the images. I pasted that. So I think it is clear for everyone.
Okay, fine. Then we can close the stream now.